Good morning, Joel Ransom, Extension Agronomist for cereal crops at North Dakota State University, and I'll be reporting on a project that was funded. It's entitled Impacts of Cover Crops Preceding Soybean. So basically there were two experiments, and I think they basically address two research questions. One would be, when is the best time to terminate rye when it's used as a preceding crop in soybean production? And we want to focus on soybean yield, soybean establishment, and weed control. And then the second experiment would address what cover crops are the best options to plant before soybean. So to describe the first experiment, which was the termination timing of rye prior to soybean planting, I'll just show you an aerial view of the actual plots. And basically we had 5 treatments, one where we terminated 2 weeks before soybean planted. The second, we would terminate rye 1 week before soybean planting, then one at the time of planting. The next would be at the time, 1 week after planting, and the final would be 2 weeks after planting. So that basically a very simple design, and the idea would be to look at the yield and establishment of soybean at the different timing of rye. So first data I'd like to show you today would be looking at the stand establishment. We had 2 locations, one in Comstock, and this first one would looking at establishment, different timing. As you can see, that basically soybean stand establishment in this experiment actually improved as we delayed the termination of rye. I don't have any good explanation for why we saw that result, except perhaps the soil was a little wetter when we terminated early, and maybe it was not ideal for soybean establishment. In Chaffee, however, our second location, we had a very different response, and in fact, as we got into the later termination timings, 1 week post and 2 week post planting, we see that we had a significant reduction in soybean establishment. And I think that the key point here was that this environment was quite dry. Just to give you some idea what it looks like at different timing, here you can see, this would be early timing plots. This would have been kind of what the rye looks like at, and this is we're talking about 2 weeks after planting. Sorry, this would have been probably 3 weeks after rye planting, and you can see that there's a fair amount of biomass still on the surface. On the latest termination timing, there's quite a bit. In fact, there's almost standing rye still there, and it's just starting to die off. And this is a picture a little bit later on, and you can see that some of that late rye, it fell down and performed a nice canopy over the soil. And we see that perhaps a little bit of growth reduction in some of those plots that were terminated late. Now, what was the result of termination timing as far as rye biomass was concerned? So this would be the rye biomass at the time of termination, and these will be the lines here, the 2 locations, and you can see that really prior to planting there wasn't a lot of rye biomass, and so by about the time of planting, which was around the 20th of May, we see a pretty dramatic increase in biomass, and we get very significant levels of biomass by 1 and 2 weeks after planting. So I think that's a critical point, is if you're interested in rye biomass, that you really need to kind of hang on and delay your termination to at least planting. And then this, only at one location, we're able to gather weed data, and you can see that as termination timing was delayed, that we had a significant reduction in the amount of weeds that established. So by the 1 and 2 weeks after planting, very little weed development occurred. And this was really 4 weeks just prior to our second herbicide application. We weren't able to collect yield on these experiments this year for a number of reasons, but I did put some yield data from last year at 2 locations, and just basically looking at the yield column, you could note that we really didn't see a yield reduction in 2019. Now, I'm pretty sure that if we would have been able to carry these other experiments to yield, we would have seen a very different scenario. And I'll show you some data from other experiments that would kind of substantiate what I want to say. So the observations from this first set of experiments was that terminating rye at or after soybean planting resulted in a dramatic increase in raw biomass. I think delayed termination of rye did reduce soybean emergence when conditions were dry. And so this is kind of a critical issue, that if you're going to terminate your rye, you have to more or less predict what kind of weather you're going to have. And if you have a dry season, probably better to terminate earlier than later. But if there's plenty of moisture in the forecast, I would say these later terminations are better because they result in much more biomass. I think we can reduce weed development as we delay rye termination until after planting, and we didn't get any yield data this year, but I think that, as I mentioned, we didn't see any reduction in yield last year. Probably we would have this year. In the second experiment, we looked at a number of different species of cover crops that preceded soybean and tried to get some yield data on soybean as it impacted by cover crops. And so here's a picture of winter rye and winter camelina, other plots that died out in the winter because they were not winter annuals. And just looking briefly at the yield at our Northwest 22 location, one can note that really there was no, and we didn't get a lot of fall biomass because it was such a cold fall in 2019 in fall, but we did get pretty decent establishment of our rye and our winter wheat plots in the spring. And you can see that we saw a slight reduction in yield in those two winter annual plots. And I think this would have been one of the reasons that I would suggest that there may be a yield drag associated with rye and winter wheat when we plant soybean after it, if we terminate it at the time planting or later. And this is just another experiment to kind of confirm that. You can see we've got rye, camelina at different stages of development in the spring. Those were terminated at the time of soybean planting. Kind of see what the biomass looks like. This is camelina, doesn't do particularly well when planted early. And if we look at the yield coming after these crops, again, we see that rye has a slight reduction, whether the rye was planted at the V7 stage of corn or at the R4 stage relative to some of the other cover crops that we had planted. So I think with that, when terminated at the time of soybean planting, potential yield drag was noted when rye or winter wheat was the preceding crop. And I think depending on plant development and the environment, camelina may be beneficial or may be detrimental to soybean. So we had kind of a mixed result in those in that regard. Now for the report on the on-farm research relative to the same topic, we'll have Jesse.
So thanks, Joel. As Joel mentioned, my name is Melissa Carlson. I'm an on-farm research coordinator for Minnesota Wheat's On-Farm Research Network. And kind of the second part of this trial, we had a few large plot locations to go along with some of his small plot research. And what we were doing was just looking at measuring some variables on what it looks like to seed the soybeans into the living rye versus just having no rye. This last year, and then in the fall of 2019, we were able to establish two locations of large plots just before the rain started falling in the fall of 2019 in Dorothy, Minnesota and Warren, Minnesota. And so both were planted, or both fields were worked a little bit before the rye was planted in the fall. And both fields used a hoe drill to plant the rye. The Dorothy field was at 20 pounds per acre of rye, and then Warren was seeded with 30 pounds per acre of rye. But then in the spring in Dorothy, because they were solid seeding their soybeans with that same hoe drill, they actually found out they needed to go over the entire field with one pass of a Salford vertical tillage implement in order to get a good seed bed for the soybeans, since the rye was tangling up a little bit in their hoe drill. And so they actually worked the whole field first before planting their rye, and then the rye was terminated about a month later with a combination of Roundup, Dicamba, and Zidua. Although in Warren, in the spring, they had no additional field prep, and they were able to use their row crop planter with double disc openers and 22-inch row spacing to plant their soybeans directly into the rye. And that field was the rye in that field was terminated about 3 weeks later with Roundup and Ingenia. So these are just two pictures of what each field looked like in the fall, just prior to freeze up. So this is taken at the end of October. The field on the right is in Dorothy. Or sorry, excuse me, the field on the left was in Dorothy. And you can see we had a lot of good regrowth. That's a combination of volunteer wheat and cereal rye there. So we had volunteer wheat come up in both locations. And so that's one thing to think about when if you plant rye in the fall, following wheat, is you'll get a lot of volunteer wheat growth back in the fall, but obviously only the rye is going to come back in the spring. And so in the spring, we had good regrowth at both locations. And you can see on the left there, you can see the difference between the control and the rye treatments. And then also what it looked like after the field was vertical tilled and prior to planting. And then in the picture on the right is a picture at the Warren location after they used their row crop planter planting into the rye. And unfortunately, in the Dorothy location, we did have a poor soybean stand establishment, but that was actually due to a bad seed lot, poor vigor and germination. Just happened to work out like that. I think in our stand establishment in Warren worked out all right. And so here I just wanted to show a little bit of the biomass, the total dry biomass that we sample up from each location. So we sampled twice at each location, once at planting and then once at termination. So you can see there's, because the vertical tillage implement thinned out the rye quite a bit in Dorothy, we had some rye surviving, but still pretty thin stand by the time of termination out there. However, in Warren, in 3 weeks, you can see we got quite a bit of growth. So under Warren, you can see that picture in the middle on the right side was at planting, and then the termination timing picture on the far right picture. You can see the rye was fully headed out and had already pollinated it by the time it was terminated. And so we had quite a bit of growth. So I included some pictures of some strawberry bales down there just to help you get an idea about how much biomass that would equate to being out in the field. And so some of the things that we measured in the field during the season, so we measured soil nitrate, residual soil nitrate at planting and at termination. So here's our differences in soil nitrate between the two treatments at planting. There was some small differences in Dorothy, no differences in Warren with that small amount of rye growth that we had taking up nitrogen. But then by the time we got to termination, we could see some larger differences. So that thin stand of rye that we had left over in Dorothy did actually take up a little bit of nitrogen. So we did have some significant differences there. And then in Warren, down below, we can see we had quite a bit of difference between the two treatments with the amount of residual nitrogen that was left over. So the rye ended up taking up almost about 40 pounds more nitrogen compared to the control. So that was quite a big difference. We measured soil moisture at planting, but that would be the 0 weeks, and then 2 weeks and 4 weeks after planting. Not a lot of differences in soil moisture between the two treatments. Warren did have a little bit of a difference at the 2 week after planting timing, but otherwise not too much. The more interesting thing that we measured and were able to look at was weed pressure. So we had weed pressure at planting, 2 weeks after planting, and at least at 4 weeks after planting in Warren. And we had significant differences in weed pressure using the rye to help suppress the weeds. And so we can see first off in Dorothy on the top table there, we can see significant weed reductions using the rye compared to the control. And so both of those pictures on the right are actually of the Dorothy location. That field had a bit of a foxtail barley problem. So you can see that picture above is of the 2 weeks after planting timing. And you can see the weeds coming up there in the control treatment. And then in the picture down below is actually, we can see the control on the left and the rye on the right. And we had significantly fewer weeds in the rye plots. And then the consultant also told me that the weeds in the rye plots were also much smaller and farther behind than the weeds in the control treatment. So she was seeing some weed suppression with the rye treatments. So that was really encouraging to see. And then down below, the Warren location just didn't have a whole lot of weed pressure. And so we can see that there was a little bit of, there was still some differences in weed pressure. You can see definitely at the 2 weeks after planting timing, but far less than what the Dorothy had. So some encouraging things or results to see there. Before we get towards before we finish up, one thing that we did run into, we had yellow beans at the Warren location in the rye plots. It was very blatant that it was because of it was due to the rye. And my first thought when I was out in the field was that it looked like a textbook IDC problem with yellow upper leaves and stunting and terminal fluorosis. I just could not figure out why that might be or what the rye might have been doing to cause IDC when there was no IDC in the rest of the field. The control treatments and the whole rest of the field was very green and healthy. But one thing I did read about was sometimes when there's a lot of biomass, when there's a lot of straw breaking down, that can tie up some of the nitrogen in the soil as that straw is breaking down. And so even though we had green beans earlier on in the season, as that after that rye was terminated and the straw began breaking down, it might have tied up a lot of the nitrogen in the soil. And so what we saw might have been a combination of IDC, of nitrogen deficiency, or an interaction of both. I'm just really not sure. And I included some pictures of the soybean nodules because those seemed to be affected too. We didn't do a formal sampling or analysis on the nodules, but just tried to get a grasp of what was going on. And the green, healthier, taller soybeans had lots of nodules, and those nodules were red and actively fixing nitrogen. And then those yellow, stunted soybeans, fewer nodules, weren't red, weren't actively fixing nitrogen. And so sometimes the conditions that cause IDC can also inhibit nodulation too. And so it just might have been a perfect storm of things. So not 100% sure on the exact cause, but just something to note that we did run into with the rye. And that yellowing and stunting did affect the soybeans' height and yield and Warren. So we can see these are the soybean plant heights at Dorothy. The soybeans in the rye treatment were actually a little bit taller as those soybeans were reaching up to get above the rye. But in Warren, we can see that the soybeans in the rye were actually smaller or shorter than the soybeans in the control treatment. And again, it was due to that yellowing stunting that we saw. And it did have an effect on yield. So up above in Dorothy, we didn't have a significant difference in treatments between yield, although the rye might have yielded actually a bit better than the control, but that was not a significant difference. But in Warren, that yellowing, that stunting did have a significantly negative effect on the yield. So we can see about a 7 bushel yield decrease in the rye there. And so I think the story to kind of go with that and to kind of tie it in with what Joel had talked about earlier, just had to do a lot of termination timing, maybe, and the amount of biomass that we were dealing with. So both locations were terminated at about the same time, but the Warren location had far more biomass than what the Dorothy location had, and so there was just a lot more competition with the rye and the soybeans with a greater amount of rye biomass. And so I think as we continue researching and trying this out, it's just underlining the importance of making sure that we're being aware of how much the rye might be competing with our soybeans and maybe erring on the side of terminating too early rather than waiting until later on when they might be reducing soybean yield. And so with that, both Joel and I will take any questions. And we'd also like to thank the Minnesota Wheat Research and Promotion Council and the Soybean Research, Minnesota Soybean Research and Promotion Council for funding this research. And so both Joel and I are available to take any questions you guys might have in the time remaining that we have.